I'd like to introduce our moderator, Dr. Dan Reed. He is formerly of Microsoft, and we are so lucky to have him as our provost. He's the Senior Vice President of Student Affairs here at the University of Utah. He has a resume a mile long, as do everyone here. As does everyone here. He has served as a member of the U.S. President's Council of Advisors on Science and Technology and the President's Information Technology Advisory Committee. And then behind that comes everything you would want someone sitting on that committee to have. Next to him, we have Bassam Salem. He was born in Egypt, lived in France and England, came and immigrated to the U.S. When he was 12. He started, I guess he graduated from high school, and he yes, he did graduate from high school.
Good to know.
We're so lucky to have him here. He started.
It was East High School, though, so it was really cool.
Yeah, take that into account, right? Okay, so he was programming professionally at age 15. That's not what I was doing at 15. He completed his first master's degree at age 21. He earned a BS, an MS, a Master's of Philosophy degree in computer science, and an MBA. He is the CEO of AtlasRTX. It's a consumer engagement platform combining artificial intelligence, text messaging, and human augmented engagement to allow businesses to offer the customers that real-time experience that they expect. Next to him is Glenn Colby. He is the founder and president of Invarius. He is an accomplished senior executive engineer and innovator. He has more than 34 years of success in aerospace, defense, telecommunications, and consulting industries. He has led the development, I love this so much, of major aerospace systems, including manned and unmanned aircraft, as well as satellite navigation and communication systems. He uses artificial intelligence related to drone autonomy and swarming to cognitive communication systems and deep learning-based network operating systems. Say that real fast. And then on the end, we have Keelan Johns. He is a graduate of the David Eccles School of Business. He is the senior director of engineering at Clearlink. He got an undergraduate degree in finance from the University of Washington, and he's worked in web analytics at backcountry.com. I think we all know that company. He leads engineering teams to support telephony implementation, HRIS and WFM systems, ETL and data warehouse, customer tracking, and analytics. That's above my head. So without that, we'll turn this over to you, Mr. Reed, Dr. Reed.
Okay. We're going to try not to geek you out here and talk about sort of a bunch of issues related to AI business and how it affects our lives. So depending on where you sort of first started to think about AI, maybe it was HAL in 2001. That's sort of the vintage I was. Maybe you were afraid of Skynet and the Terminator movies. Or maybe it's a more recent set of things involving realistic robots affecting our lives. None of those things are really true. They're sort of the movie version of things. So I want to start by framing a question about what AI really is and what it means to people. And there's an old joke in the AI community of people saying AI is whatever we don't yet know how to do. After that, it's just technology. So we'll just go down the line and start with, as you think about AI, what do you think about its capabilities and what does it really mean in the context of where you're working?
Well, I'll go ahead and start. I think I define AI simply as automating what humans can't do or don't want to do. That's sort of how I see it. I feel like there's so many things that we could argue today is already artificial intelligence. I would contend that a calculator is artificial intelligence. I'd certainly prefer to use a calculator to multiply 4-digit numbers than to do it by hand. I still know how to do it since I did go to East High School. But artificial intelligence to me is nothing more than doing what we don't or can't do. I'll keep it at that.
Yeah, I think about several things. One is just doing things that are routine and doing it better than a human can do, and then freeing up a human for other tasks. But I think in terms of scale, there are things that just humans have very difficult problem getting their hands around, whether it's, think of your big data examples, Earth climate, those sorts of things. So you can bring that into the conversation of how it can help. I think also, humans are limited by how we learn in our perception, and AI brings in the ability to analyze things outside of our biases or preconception. So there's some of those things that I think about when I look at what AI can do.
So to add to both of those, which I agree with, I'd say I look at AI and machine learning more from a statistics bent. And statistics is estimating, independent variables based on, or dependent variables based on independent variables. Machine learning and AI basically takes that a step further and automates it. So tunes a statistical model by itself. That's the basic definition that I use to think of what differentiates, decision making from statistical decision making to automated AI.
So as each of you sort of, and we'll maybe come back in the opposite direction, as you think about how the advances of AI have evolved over, say, the last half dozen years, and AI has gone through multiple booms and busts. The AI community talks about AI winners when there was much hype and overpromise and reality under-delivered, and then new advances would occur, and there'd be new excitement, and there'd be another valley. That's happened multiple times over the last 30 years. So as you sort of think about where we are now, how do you see AI affecting your company and its processes and its products and its future?
Yeah, one word, accessibility. I think a lot of AI and the approaches that we take to AI have become easier to access over the last 10 years, and it's primarily due to cloud computing and open source software. I think there was a huge burden to entry creating the systems which kind of led the charge, and that probably is one of the first kind of booms you're talking about. The open source community has taken that and extended it in a few different ways, and then corporations, cloud companies have used that to basically enable it to be available to all of us for really cheap and really accessibly. So I'd say, accessibility is the difference now than ever, and cost for that accessibility.
Yeah, Keelan, I think that's a great point. I mean, we've gotten to the place where access to the cloud and the computing is a commodity, and it's really changed the whole ballgame. So whereas before it might have been the sole province of Google in the early days and the Amazons and so forth, now even small companies have access to the resources that can make them competitive. So I think that's a huge game changer. The other thing that I think has really taken off is on the education side, is having access to the people and the training to really be at the forefront here. So the resources along with the commodity availability of the processing and the access has really changed everything.
I completely agree. I do think that as a computer scientist myself, one of the frustrating things about AI is it's sort of so macro, so massive of a definition. It covers so many things. And it's really hard to talk about it in the aggregate. I'll tell you, in my world, we focus on a specific type of artificial intelligence called conversational AI, conversational artificial intelligence, this notion of a computer program that is able to have a conversation with a human and get things done on their behalf, answer questions on their behalf. And Dr. Reed, to your point, when you talk about the booms and busts, I still remember ELIZA, the cool program. I don't know if any computer scientists are in here in the 80s and 90s.
Anybody heard of ELIZA?
ELIZA? No.
We should probably tell you what it is then. Go ahead.
I won't bore you with it, but it was it was really cool. It was a program that could have a faux conversation with you. It did not understand what you were saying, but it certainly looked like it understood what you were saying, and it really confused a lot of people I think it was in the 60s actually that ELIZA came about, but certainly in the 70s and 80s, this notion of, are you kidding me? A computer program is asking how I'm doing, and when I respond, it responds back. And it was very sort of surface level, but it tricked a lot of people into believing it was it was a human behind the computer screen. So that is the sort of AI we're living in today, and I think we have finally evolved to the point where natural language processing, an acronym called NLP, natural language processing, a computer being able to understand natural language, understand what we're saying, and deduce the meaning from a question or the meaning from a request and do something about it. I really think we're finally there. We're finally there being, we're 70 or 80% of the way there instead of 20 or 30% of the way there. We can deduce so much meaning from conversation in a computer program and have that computer program then be able to do something about it. We're all experiencing that with Siri and Alexa. We're starting to see the differences between how those work today versus what it looked like 5 years ago, and then certainly 10 years ago when it was really difficult. If you have Comcast, I don't know how many of you are blown away by how effective the remote is at figuring out what you're trying to say. So in terms of how I see things shifting, and I'll keep it to that notion of AI, over the next 10 years, I think so much of our interfaces with our world, with our devices, with computers, is going to turn into a conversational user interface instead of a graphical one. We're going to talk to things, we're going to text things, and those things are going to intercept the human and work on their behalf and assist them. And I liked your comment, Glenn, about freeing them up to do things that matter. So if you have a basic request, why not have a computer program just handle that request for you? So I really foresee the next 10 years being the 10 years, the decade of conversational AI becoming very, very mainstream, and something we just are accustomed to in just a few years.
So you talked a little bit about how natural language processing was a driving force in your company, and I'm wondering, Glenn and Keelan, if you might talk a little about your companies, about how AI is affecting your business.
So I do a lot of consulting, and I work primarily in the aerospace arena. And one of the things that AI is enabling is the ability to solve essentially hard problems that we haven't been able to solve before. One of my companies that I'm supporting, that's a startup, is a satellite-based laser communication system. And one of the challenges with satellite is, if you just looked out behind you and see the cloud cover, is that you can only get, with laser, you can only get through a very little bit of that. It could be anything, smoke, it could be anything that's happening locally. And then, of course, you've got a very complex set of demands that are coming to you from users and so forth. And so at some point, when you take the old paradigms of satellite communications where everything was managed manually, some of these new technologies are simply impossible to manage effectively through manual intervention. So one of the things that we've been able to do is help companies understand how to use AI technology to make these things possible where they weren't possible before. And so that's primarily the area that I work in, is trying to solve hard problems. And one of the really interesting things too, especially for those of you who are familiar with deep learning, which is techniques that allow you to understand things without having to pre-format or label or do things ahead of time to try to put it into certain constraints, is that you get insights from the artificial intelligence algorithms that are different than what humans might come up with. And in fact, there's been a lot of articles written about this, that deep learning techniques can actually make decisions and the scientists struggle to understand, well, why did you make that decision? And there's profound implications, whereas it could be very effective for your business, but how do you relate it? Like going back to a decade of natural language. Well, if you make a decision, but you can't really explain it in human terms, that makes people very uncomfortable. So, we have primarily focused on how do we solve hard problems, and most of those problems haven't been at the forefront of, say, consumer or personal interaction. It's just been technology.
Yeah, great. Let me give a little bit of an overview of what Clearlink does, and that'll frame kind of two bents we take towards AI and machine learning. We're basically a marketing and sales company, so we primarily market online and sell over the phone. But there's basically three types of ecosystems of data that we support. So that's your web analytics, what your visitors are doing on your websites, what they've done prior to your websites, to get to your websites, and how they navigate between and within your websites. So there's a whole lot of data. Every click, every action's tracked, and that's assume many of us are familiar with that. We primarily drive inbound phone calls, which is telephony data. So we'll touch on NLP and sentiment analysis and conversational analytics in a moment, but again, that's a whole separate ecosystem, a separate type of technology with a whole different set of challenges. And linking the two has its own set of challenges. So going from an online experience to a telephone experience is, for the customer, just part of the sales process. It's organic and natural, but from an engineering and from a data and from an analytics standpoint, they're decoupled. And then obviously the way we monetize all of this is through selling products on behalf of other companies. And again, that is a whole other set of data. Primarily our conversion metrics are matched through that. So whether it's orders, units, whatever, that could be in our homegrown order entry tool or a partner's. So what we're faced with often is decoupled complex ecosystems of data. And so we've kind of got, like I said, two ways that we use AI or are working to use AI to automate and to optimize those systems. So before I jump into NLP, the first one that we're doing right now is basically, you can think of it like inventory optimization. We have levers to drive customers to the website, like paid search. You can pay to advertise on Google, and we all use Google, so we spend a lot of money there. But that money's only well spent if it results in a conversion for our business, right? Otherwise, there would be no balance of value created by spending money on Google. So the other constraint, so dollars and volume of traffic to our website is one constraint. The other constraint is the size of our sales floor. We're driving inbound calls, and a person can only be on the phone with one person at a time. So we're constrained by how much we can actually service our customers, and that's basically the number of sales agents we have available to take calls. So what once may have been like statistical analysis for us is now an actual, live machine learning implementation, where we basically estimate the volume of traffic we could drive to the website in the next 15-minute interval based on dollars we spend and the conversion rates of those visitors to calling in. And marry that up, at least look at the delta between that number and the number of agents we have available on the sales floor. And what makes it machine learning is predicting in the future, in 15 minutes. Not right now, not earlier today, not yesterday, but what's going to happen. And the reason we have to do that is because there's a lag. If you spend money on Google for paid search, it has an effect, not immediately, but in 15 minutes. And that's due to the tuning of their algorithms to pop you up in the position of paid search, as well as the time it takes just for a visitor to click the website and actually make a call. So for us, it's really tangible. What an implementation that kind of is critical to our business and had been something that analysts had managed in the past or sales leaders had staffed to in the past. And absolutely forecasting is a major part of that. But optimization and kind of, it's not arbitrage, but close to arbitrage. It's really inventory and demand optimization is improved using machine learning to do estimations for what's going to happen in the very near future. And it self-tunes every 15 minutes throughout the day, but that's kind of the most practical, I'd say. You have a set of independent variables as an input, dependent variables as an output, and you have action that the business takes as a result of that. And that action is bidding on certain campaigns in Google's paid search or removing campaigns from being bid on to basically change the volume of traffic. So that's a really operational, mechanical example. But again, NLP, conversational analytics, intent of the customer is the other half that is burgeoning right now. And similar to other like frameworks for machine learning or AI, we are early at the dawn of widespread adoption of NLP and conversational machine learning. And so we're in the early phases of basically taking a legacy approach to this technology, to the technology used for having conversations, and retrofitting it with these either bots or analytical engines which analyze conversations, whether it be voice or chat or whatever. There is nuance to different mediums for communication, but the intent's the same. We're trying to figure out what the customer wants, when are they happy, what do we do to effectively meet their needs, and how do we service them better and faster. So on that side of the fence, there's a little more that, we're at the early phases of doing it, but the intent is really similar in our case.
Okay.
Yeah.
So our panelists said several magic words, and I want to sort of pick up on those. Throughout most of our business history, we have struggled to acquire enough data, right? And that's what business analytics is about. It's about data to do forecasts for sales, and it's all about how to understand what the customers are doing, what the business is doing, what the opportunities are. And in most of our history, we struggled to get enough data. That's been a big challenge. We're actually in an interesting situation now where we have an amazing amount of data, and part of the struggle, as you just heard, is how to get insight from that data. As we started talking, humans are not very good at doing the same thing over and over again. We get tired, we get bored, we make mistakes. That's one of the great things that computing in general, but AI has automated a lot of those things. So one of the questions I wanted maybe to explore is, there's sort of two ways you could look at the world about questions. One is, I have questions. There's a whole bunch of data. Give me some answers to those questions. The other, maybe more interesting one is, what interesting answers are there in the data that I haven't thought to ask questions about first, right? Which is part of the, how do I automate a process that could go off and learn? And there's a lot of interesting things happening now in automatically training systems to do stuff. So here's a really maybe scary to some of you example. The ability to generate synthetic faces that look like real humans, the humans can't tell from photographs. And when you couple that with natural language processing, you actually have synthetic humans talking to you. And so the question I want to really pose is we think about that world where we're building systems that are automated and they are learning from data and may behave in ways that we don't expect sometimes. How do we sort of manage that consumer and business expectation of reality so we don't scare our customers, but we also don't build bias into our AI systems that, for example, might discriminate against certain customer classes or certain behaviors? Any thoughts on those things? That's a pretty open-ended question, so ramble away.
Yeah, so I think there's a great example that's been written about in Amazon, where there's been so much competition going on trying to influence Amazon ratings, because Amazon's own AI algorithms will sort you and even kick you out if things happen. So one of the examples is there's been a huge controversy about fake ratings. Mm-hmm. And for a while, companies, you could pay them and they would just put a whole bunch of great ratings on your product. So what people would do is, once the algorithm started to recognize that, they would put fake ratings on their competitors, so their competitors would get banned or temporarily taken off. And so it's kind of like the history of warfare in retail right now, because mm-hmm. it's been evolving very, very quickly. Another example is putting a safety concern, so paying people to say they bought the product and then saying it was unsafe or it caught on fire. Well, that will flag the algorithms. So there's been this constant, warfare, if you want to call it, on these things, and how you can come in and influence competition for your own benefit. So it's a really interesting topic to look at, and there's examples of this in many different arenas related to business in general.
Maybe I'll add I've been digesting the question. It's a really, really good and a tough question. I do see sort of a counterpoint to that, and that is, as I see even our own capabilities in conversational AI, the more we evolve, the more we're able to allow the conversation to flow in a very free form, very unstructured way. When you go and interact with a system, and the system is sort of directing you down a path because it's trying to vet whether you're you're choosing A, B, or C. And then when you go to B, it's choosing D, E, or F. It's sort of routing you in a very sort of formulaic way. It's not how a brilliant human would do it, but it's certainly, if you want to build a human at scale, how you would program a human. You would tell your call center staff, this is the script, follow the script, and go down the script and guide them as efficiently as we know from a very company-centric view of what the flow should look like. I think as we get better and better and we have access to more data, there's sort of this reinforcing cycle, because ultimately, wouldn't it be nice if the faux persona that Dr. Reed is referring to could greet you and say, how may I help you? And you can now go anywhere. You can free flow. And in fact, if you could free flow, then you may create more data for us as a company, for us as a brand, for us, right, as the data provider, the service provider, to recognize that maybe we were guiding the customer in a less than efficient way, or maybe we were guiding the customer to a frustrating experience because they always want to go here or they're identifying areas that we had not thought of. I really feel like we are going to end up with capabilities and knowledge that we didn't have before, because computers and programs and scale, the scale they provide, is going to enable us to open up much more sort of varied and less than defined possibilities. So I actually see the positive of it making things easier for us because of that flexibility.
Well, I think that's true. Technologies historically generally are neither good nor ill. They simply are. It's a human choice about how we use them. Maybe even let me crisp the question a little bit more before the other two of you jump in. If you think about the way that we build systems that gain insights from data and identify correlations, there are both social and economic questions about ethics and fairness that go into that. So, for example, if you build a system, and there are ones out there that help pre-qualify people for loans based on their financial background and a profile of them. I mean, there were good things there, but there is a slippery slope about where the learning system builds in discriminatory or unethical behavior. And so part of the question I was really trying to ask is, how do we balance that sense of, yes, freeing people and letting them do things, but also building in ethics and responsibility and appropriate behavior so that our systems, as we give them control, don't wander off into territory that violates our sense of fairness.
Independent third-party audits. No, I'm just kidding a little. They do help, though. I would say, like, you're talking about cybersecurity as well as ethical implications of that, and so I think audits as a standard mechanism for ensuring that you are conforming to secure best practices are a good place to start. Absolutely, and it's kind of a part of the industry that's really taken off as unethical behavior has happened, whether it be in a financial industry or personalization for a given customer, it doesn't really matter. So I'd say that's like the bottom of the safety net, and it's the guiding light for a standard, but it's not necessarily the ideal state for how we would like to operate this. I'd add one other thing too, is in the original question you discussed kind of 2 points, and one is the types of data, structured data, how it's used, as well as kind of the implications on how it affects, ethical behavior. So I'd say there's sort of 2 types of data. There's analytical data and operational data. To do AI, you need to use operational data in an analytical way. To measure it, it needs to be structured for analytics. So recognizing the difference and recognizing the technological differences that need to be implemented, and the processes around each of those 2 types of data, even though it may be the same thing that you're measuring or thing that you're optimizing in operations, I think it needs to be we need to be reminded to look at the 2 pieces of data differently. So whether that results itself analytically in reporting or statistics or audits, that's kind of the after the fact evaluation that we can do on data, and that may allow us to identify things that we did improperly or that we tuned incorrectly, as well as, to your point, what did we miss? What did we, what did the operational machine learning implementation do is measured via analytical structured data.
Yeah, I wanted to add, IEEE came out, I think it was last year, with ethical guidelines on AI implementation. There's really 3 pillars to it. One is human values. The second is self-determination, meaning that you've got control or your own data. And the third is trust. But even when those are great principles, but even when you examine those, there are challenges, right? I mean, even around the world, do we all agree on human values? Do we all agree on self-determination of data? Maybe in China, the idea of self-determination of data is different than it is in the United States. So even with broad frameworks, there are challenges with these things.
And yes, go ahead.
So I'll try to keep it brief if I could just add, because I think, Keelan, your point, I agree with. I'll sort of rephrase audit as human oversight and human involvement in the training and education of a bot or of an AI mechanism of some sort. But the bigger point that I sometimes wonder about is, are we expecting these systems to have a different bar than we're expecting humans to have? And is the bar really, as long as you're better than a human, there's still value in it? So I dare say humans are racist, humans are sexist. So if we can just make machines less racist and less sexist than the average human, we're getting better. I say that bluntly because that's the truth. We deal with salespeople who are racist, right? And we as companies hire these people not knowing it. The bar for AI could be exactly the complement of that. Can we teach machines to be less racist and less sexist? They're not going to be perfect. And I say this as a minority myself, right? But I contend that they'd be better at it than what is a relatively low bar in humans. And I'll put a real world example today. We talk about driverless cars crashing and the rate of crashes that they have. Should it be perfection? Should the bar for driverless cars be 0 accidents? Or should it be 50% better than a human driver? And I'd contend it's the latter. As long as it's better than a human, we're okay. We're getting that benefit. But I realize that there's a bit of moral hazard as we discuss these sorts of topics, and it's a sensitive topic, but I do think it's not as black and white as a perfection bar would imply.
So there's I sometimes share a version of that sentiment, and I remark there's a lot of interest in what's in some circles called explainable AI, which is to say, how can we understand how those decisions or predictions were made? We have millions of 16-year-old drivers on the road. We have no idea how they really learned to drive, and we've made peace with that. Maybe an uneasy peace, but we have made peace with that. And so there are some deep social as well as technical questions about that. I just want to ask one final quick question, and then we'll throw it open to you. So be thinking about questions that you would like to ask. So if you sort of look forward about where you think AI is going to go, what do you think are going to be the additional competitive advantages for businesses?
Yeah, I would say in certain industries, AI is more prevalent than in others, and so there's a lot of reasons for that. In aerospace, people haven't been making decisions on distributed systems that are circling the globe for many years now. And so it's sort of ingrained in the culture in some industries to have introduced some of these technologies for many years. In other industries where it's more people involved, we have relied on people. I mean, we're humans and it gets the job done. So if something works, why change it? We're coming up against that question, I think, right now in a lot of, at least my industry and others, I'm sure, automating things that humans have done. And the reason for that is obviously, optimization of the business and customer experience, but also cost. And that kind of touches back on the accessibility of these tools. You don't have to go buy a supercomputer. You can rent one for an hour. And it's cheaper now. So I'd say the equation for the cost to value is starting to equalize for industries where it just hasn't in the past, and there haven't been, billion-dollar publicly funded, reasons for getting into it when it was, first of, I guess, bleeding edge. We're maybe now first to follow in some other industries. So, yeah.
Yeah, I think that's a great point. I mean, I think your own business, right, is a perfect example of being able to provide value in very much real time to a company, and then you can see the results. And when I look at the promise of NLP, it's sort of the same thing. I mean, you're completely changing the experience that consumers are having with a business, or even in a business to business. And then, in my area, it's about, again, solving those problems. And the interesting part of it is, although we tend to think about AI as being a smarter human or a little better than a human, the really fascinating stuff is when AI doesn't think like a human at all. We've defined intelligence according to how humans think and how they operate and how they process. Well, we're going to start learning things about intelligence that's completely outside of our human experience. And it's going to be very challenging. It's going to be socially and politically challenging. But it's going to be a tremendous learning experience for us as humans. And there's tremendous business potential there as well. I mean, this is something that governments in the world are already very aware of in terms of the potential. It's driving economic competition. It's driving political competition. This is already well in progress. This is not something that's going to happen 5 or 10 years from now. That competition is happening today.
I won't add to that point. I think you guys have nailed it. But Dr. Reed, I do want to say I appreciate the fact that you're bringing up some of the ethical questions and challenges that we're dealing with, because that's one thing we are certainly dealing with on a daily basis as we talk to businesses who are trying to automate tasks that are highly repetitive and high volume. And there are, I think, meaningful societal implications over the coming decade on jobs that exist today across the country and across the world that are highly repetitive and have high volume. I mean, certainly tier 1, as we call it in the business, call center work. If you're just a tier 1 call center agent, we have to train you to do something else, because that task is likely something we can automate. Some are arguing, I'm not so sure, but some are arguing truck driving, which is a very, very, very prevalent profession, could be at risk over the coming 5 years. Again, I'm not so sure. I'm actually wondering if it's easier to fly a plane without a person than it is to drive a car without a person, because you're not dealing with a million different things. But suffice it to say, there are lots and lots of jobs, lots of careers, and therefore societal implications on AI and the pace of change that AI is taking and has taken over the last decade. I mean, we are meaningfully improving now. It's that we're starting to really see that curve up. I'm sure all of you are baffled when you see Facebook recognizing your picture automatically, very, very accurately. It's crazy how well that is working. So things have just come such a long way in the last 10 that I can't imagine that the next 10 are really going to change our choice of careers and our I'll keep it at that, but the economic implications are pretty high.
And I'd be remiss and so please think about a question. We're going to have the mic go around because we are recording this, but because we're on a university campus, I'd be remiss if I didn't at least briefly comment on that. Think about the context of routine cognitive tasks, and those are really the ones that were being talked about. Those are very amenable to automation. But there is also, and we often think of those as blue-collar or entry white-collar tasks. The non-routine cognitive tasks, many of those are increasingly approaching opportunities to bring AI technologies to bear. Those things have some profound implications for how we think about society and business and everything else. So questions, please.
Just related to what you asked, what you just mentioned was,
Yeah.
Just related to what you just mentioned was automating tasks. What would you say is the difference between automating a task versus having AI accomplish it in a different way? And then also for small to medium companies, what's the maintainability like when you do choose to have UI do something rather than automate it?
Jump in.
So automation doesn't necessarily mean AI, but sometimes automation requires AI to do the automation. So yeah, I think that's the really broad answer, I'd guess. But sorry, what was the second question?
For a small, medium-sized company, what's
Yeah.
the maintainability of
Yeah,
So AI maintainability for small business.
yeah, and I'd say that's kind of goes to what I was saying earlier regarding the expense for this and the accessibility. The body of knowledge that we share is bigger now, and the costs have come down. So, small and medium businesses may, I don't know what the threshold, your definition of that is, but may not be using AI yet, and that the availability of tools and knowledge and resource to implement these systems is coming. And I mean, I just am saying I'm noticing it from, a medium to larger size business. We're, implementing it now, and 5 or 10 years ago, that wasn't quite the case. So I think basically we're just reaching the cost to value equation, and the cost is dropping such that it can be implemented by a wider array of groups and companies.
Yeah, one brief comment is I think that there might be a tendency as the technology becomes more available to look at it as sort of a one-time thing. Oh, I'm going to get this AI system in and do this with it. It's really a continuous investment. And you can see how quickly the technology is changing and how quickly algorithms and efficiencies happen. So this is something that you have to think of as a long-haul commitment in terms of its payoff for the company.
That was going to be exactly my point, so I'll keep this super brief. The cloud enables that, of course. The cloud now enables us to provide AI as a service. So you can deploy it now, and we can continue to refine it over time and continue to improve it. But I think your question is really astute, because it's akin to training your employee force. We're now doing that with an AI system that gets better over time.
But there are cloud-based AI technologies where the entry point, literally for small business, might be hundreds of dollars a month. I mean, it's reached that level of accessibility.
Yep. I want to thank the guests for your expertise in sharing it with us. But I also had a question. I work in the process industries, and it's pretty data rich, and that's made it a target for deep learning attempts. But so far, we haven't really seen a lot of useful applications that have come out of those attempts. And I wonder if this is due to the errors identifying the truly independent variables in the data set. So my question, Keelan, I was interested in your forecast network. Do you ever run into problems with giving the forecast network a variable you think is independent, but in fact is not, or it's correlated to another independent variable?
Yeah, great question. And I'll extend it just a little bit. So a few years ago, the biggest problem we would have faced when trying to solve that problem would have been having structured data in a reliable, reproducible, and frequently loaded time in a common place. So that was the problem set that we solved a few years ago. And obviously there were really practical reasons for that, like reporting and accessibility for humans to access it at that time. But the benefit is that it enabled the implementation of that tool that I discussed. So a year ago when we started that project, the crux wasn't what the crux would have been a few years ago. Instead, it was identifying which independent variables were reliably, and when I say reliably, I mean we're taking day of week seasonality into account, day of year, holidays, any other events that are going on, things like that. That is what took the human element, is training the model. And for that application, it's a simple multivariate linear model. It's not a decision tree. It's not a decision forest. It's not KNN, but it was tuning the model and then implementing and testing it against status quo and then retuning the model. That was the complex part. So I don't know if that's a specific answer, other than you're going to spend a lot of time tuning a thing to optimize a low-hanging fruit type of problem that can be automated. And the other thing I'd add, I guess, is we didn't approach that problem trying to solve the whole array of business problems. It was we had a well-defined goal going into it, which was basically optimizing demand to availability. So instead of trying to optimize to other things like cost and offsetting calls to another place, or prioritization of calls in the queue, or anything like that, we simply took we're trying to match the levers that we can pull to increase supply to the demand, or sorry, increase demand to the supply that we have available. So we took a really narrow scope, low-hanging fruit, high-value problem, and then spent time figuring out what the independent variables were that actually had an effect on the goal that we had just set. Yeah, I mean, basically we just did a statistical analysis, a train and test approach. So that can happen offline, right? That doesn't need to be plugged into APIs or to your workforce management tool. That's all the engineering side. But we had data available for our data scientists to look at, start 3 months ago, train the 3 months before that, and then test it on each interval, in our case, each 15-minute interval from that 3 months ago period until now. So, and then we could validate that against obviously what we observed, and knew that, well, the decision that the machine learning algorithm would have made is different than what actually happened because humans were doing it. So then came the part of the analysis that involved saying, was that better than would it have done better than what we actually did? So there was the train and test, what actually has correlation, and then what effect did it have on the decisions that would have been made, and how does the resulting decisions compare to what we actually did?
Let's see if we can get in a question over on this side of the room.
Hi, this is Leanna. We are a huge fan of Bassam. We've used his technology, and I feel like your bot needs a name because it's so pleasant, so kind. You just want to keep chatting with it. But this is a mom question. So I watched the Columbine documentary last week. And when you hear these kids' stories, and a lot of the trauma that came is because they didn't know what was going on. So my question is, I know that you've had some large universities, some high schools, elementary schools engage with your product, and I think the intent is to let parents know maybe what's going on. It's a snow day, you don't have to drop your kids off. But has your client's intent changed with things going on with either terrorist attack or anything like that, and that your technology could save lives depending on engaging with students that are in a building? Because that's been the problem. They don't know what's going on. So I don't know if that's a specific, but just as a parent, I would hope that my kids their schools had your technology so that there was an in if something like that were to happen.
Leanna, I'm flattered. I'm blushing, even though my skin color doesn't change. I'll be honest, we've been nervous to tackle sort of higher risk, higher threat situations. I'll tell you, we have been approached about things like suicide hotlines, which are really hard to staff. Could a chatbot potentially engage a human and talk them off the ledge? It's a little scary to do that sort of thing. So but I don't think we're far off as a computer science, as a science, from tackling problems like that, or tackling problems like the one you're alluding to, where a computer program can actually be fed the latest scenarios, and when a parent is stressed or worried and is struggling to find a human, can the computer program be monitoring sources of information and updating these concerned parents? I think we're really, really close to tackling it in a very direct way, as you're alluding. Today, we're sort of tackling it passively, if I can be honest. We can certainly send out notifications and answer, a basic number of questions and sort of keep the parent a bit apprised. But I think we're within a decade of tackling these problems much more head on. But I really appreciate your question. Thank you.
Who's next?
My question is there like an upper limit to how like intelligent or I don't really know how to describe it, but it's essentially how intelligent an AI system can become.
That's a really hard question. That may be the hardest one we've been asked. I mean, part of it goes back to where we started. I'll jump in and let my colleagues jump in about what is intelligence. I mean, we are a long way from building what I would call general purpose intelligence, the kind of intelligence that a human can deal with unexpected circumstances and adapt and respond. We can build domain-specific or siloed intelligence that actually is better at those tasks than humans. If you think about what has happened in game playing, the best chess players in the world, the best Go players in the world are not humans anymore and haven't been for a long time and never will be again. In fact, one of the earlier comments about AIs evolving and doing things in ways that are different than the way we think about intelligence. If you talk to Go players, and Go is a much harder game than chess, they will say it plays Go in a way unlike any human they ever saw play the game before, in a brilliant kind of way, but very different than a human might approach it. Is it, in that sense, more intelligent? Perhaps, because it can do things a human can't, but that AI system can only play Go. Now, it can be retrained to play many different kinds of things, do lots of other things, but it's a very focused intelligence. That's why I started by saying Skynet 2001, how we're a long way from building that kind of intelligence.
Yeah, I'd add to that. Guiding light for me in engineering and software development is the UNIX methodology, which basically, to me, means a program should do one thing and do one thing really well. If you need to do multiple things, connect multiple programs together. So in this case, let's say that our problem set was AI. We wanted AI to be able to have a conversation and play Go. Well, maybe you'd actually make a machine learning or an AI bot which does each of those separate components independently, and a separate one which connects the two together. So we're basically in a world of extendability. If you make a specialized program that can solve one thing but plug in or be used by other decision-making engines, that's what opens the door to more complex, not limitless, but limitless based on your resources type of AI solutions.
Way to stump the panel, young man, because that was a hard question. I do think I can think of two practical limitations, though, that do cap the upper end. I certainly think that processing power and the horsepower of a machine definitely has an impact on its ability to reason quickly enough. So you can argue that maybe a car can avoid a slow-moving object, but a car can't avoid a bullet because it can't see it far enough until we have better, image recognition and such fast processing power that you could see it 4 seconds out and move the car. So I think one limitation is how fast and how capable computers are, and I think that one's a direct way to understand, or a direct limit we can understand. I think a harder one to understand, but I feel exists, is relating to a comment Glenn made, which is we teach computers to think in the way we believe they think, or that they should think. We're sort of mimicking humans, and naturally it feels to me that there's an implicit limitation there, that we're sort of limited by the frameworks we give them to learn within. So over time, I wonder if we come up with different models for learning for computers where they do have higher and higher limits of learning than the limits we've imposed on them today, because it's the only way we can model it. I hope that makes sense.
All right, maybe one last question, or if not, then okay. And then the mic is coming. There you go.
Okay, thank you. Well, just listening to this, I'm afraid this has kind of spawned an interesting question, at least to me. So again, predicated on what I've heard the panel articulate, would suggest that in the end, and if you go back and look at the book, The Bell Curve, which of course was always a little controversial, but the basic premise was the fact that at the end of the day, intelligence trumps everything else. And so, we've heard, for instance, Glenn articulate the fact that, excuse me, that maybe biomimetic systems are not where this is going to end up at. And as a consequence, you're going to end up with an intelligence that clearly eclipses, our, again, biomimetic, human-like intelligence. So if you start to connect those dots, is it inevitable that at some point in time, AI eclipses our human capability with some kind of nasty consequences, frankly? So I guess the question I would pose is that an inevitability, or can we build enough checks and balances into the system to make sure that doesn't happen, that at the end of the day, we're still in control?
Or is that the subconscious goal? I think there's a body of people who think that, if we can do this well, then it can be kind of the legacy humans live on, because, we have physical bodies and computers are machines, right? So I don't think we're anywhere near that by any means, but I think the conversation's being had, and a lot of the checks and balances we talked about are tangible, the tangible things we can do right now to ensure that we're building things that act morally or have positive consequences on humans. But I don't know that we've, as a body, really grasped what will it look like in 100 years.
Yeah, it's a great question. Of course, there's been a lot of discussion and debate and a lot of new efforts to develop standards and ethical guidelines and checks and balances. But one of the interesting things to me, again, going to the young man's question about what's the limits, is that even when you run, very, very intense processes with lots and lots of data, it may take you many minutes to do the same thing that 1% of the human brain can do in a second. So what's interesting, again, is how different it is, meaning that our human brains can't in real time process the amount of data and the amount of sensory inputs, right? You can take an AI system and you can have thousands, even millions of sensory inputs coming in. We're limited very much in what we can do in sensory processing. So I really see an evolution of different intelligence, because even at the difference or the delta in processing between what AI can do today and a human brain, it can already do things that humans cannot. And it's because of that change in ratio of being able to handle data in volumes we can't and handle sensors in volumes that we can't. So it's more I look at it as a discovery. We have all kinds of things that we are just waiting to discover because we've architected intelligence in a way that is both similar to but different than us.
I think that is the tough question. It's the toughest question of today, with all due respect. I think I think we project human motivations on artificial intelligence mechanisms. We project greed or self-preservation or hunger or whatever. And I'm sort of reminded, reminded by the question that Dr. Hawking posed maybe 10 years ago, where he said, what happens if we meet an alien race? Let's just hope they're not like humans. Because if they are like humans, we all know in history what humans do to one another when they occupy new lands. The lesson there being a projection of all of our sins, all of our ethical dilemmas, all of our misdeeds as humans. So I like the point that you're bringing up, Glenn, which is, could we potentially have a new definition of ethics that is not limited by potentially biological motivations that we all have that cause us to do things that I think are very unethical. And the good news is, as Dr. Reed alluded, I think we're so far off from general purpose AI that it's, I think we're easily decades out, maybe even longer than that. But I do think it's certainly a legitimate concern, and certainly something we should be aware of, because I don't think we understand how we are defining these motivations that we're programming into the AI, and are we programming human motivations or not?
So I'd just end by perhaps observing that every new technology that we have developed over the years has brought social, economic, and cultural change. What's important in each of those cases is that we have thoughtful and informed debate, because there is a continuum of right and wrong, and in the middle, some social consensus that evolves. And it's important that we be thoughtful participants and educated participants in making those choices. That's why I'm so glad you're here today. That's exactly what many of these conversations are about, thinking about what the implications and the future of things that we develop are. And so with that, I'd very much like to thank our panelists for their thoughtful observations, and thank you for being here.
Thank you.
Thank you.